that you have. And the canonical form for that is that given the security risks or threats that you found, are we done from the security point of view? Now, the team will ask this from itself, and well, I hope that they've done some threat analysis so they know that what their threats are, and if they feel that they've done everything that they can or that the residual risk is on an acceptable level, then they can say that yes, we are done, and they can move on to the next tasks. Otherwise, they really have to have the freedom to say that we are not done from the security point of view. And in that case, those tasks will not be marked as done, and they have to continue that during the next sprint. The second tool is that, obviously, for the team to be able to answer that question, they need to be able to do security threat analysis. But this is something that is now up to every organization to decide how they would be doing that. One option is, of course, to use data flow analysis and STRIDE, and that's what we also advocate. But you just have to ensure that training and tools are available for that. But you can't really expect everybody to threat analyze every single nook and cranny of the things that they're developing, and therefore we have a simple filter, a list of things which signal that you have probably a security sensitive task at hand. And this filter is then used to flag those sensitive tasks, and what happens if something is flagged as security sensitive is that the team will add a new task on the product backlog, which is actually the threat analysis for the upcoming feature. And we found this concept of a research spike in literature. Research spikes are traditionally used when a development team is about to create something that they don't know whether it works or not. So they would like to build a small prototype. They would want to try something out in a kind of maybe an ad hoc manner, and they want to reserve some time for it so that it's actually visible in the product backlog. And we thought that, no, this is an excellent way of actually making threat analysis happen in a way which makes it also visible, and so that time can be properly allocated for that. And so basically, the Scrum team, when they are going through the tasks that they are about to do, they use this filter list to identify the most security sensitive tasks. One example could be that if the task involves like sending an email or processing incoming data or something like that, then it's flagged as a risky one. And the Scrum team then adds a new task on the backlog, which is of higher priority than the original task. And that task is about threat analysis for that next task. So essentially, if every task is security sensitive, the raw length of the product backlog will basically double. But that makes it just visible that we have to do this security at some point. So then the time gets allocated and everybody's happy. And when should this sort of filtering then happen? Now, there are two options for that. And the most obvious one is in sprint planning. So every sprint begins with an activity which is called sprint planning, where some tasks, the highest priority tasks, are taken from the product backlog and put on the sprint backlog. Now, this is a good time also to do this filtering and adding the threat analysis tasks on the sprint backlog. The other option would be to utilize a concept which is called backlog grooming. That's a really weird name. But some books actually advocate the use of backlog grooming and say that any team should use like 5 to 10% of their time for this activity. And it's like a sprint planning for the future. So you will have a look at the product backlog items that you have and which you are going to be implementing in future sprints, not in the sprint which is currently underway. And you try to massage those tasks so that they are better. And so backlog grooming would be another place where you could actually identify those tasks that need threat analysis and then add the new ones. And finally then, just want to remind you that in the sprint review, the residual risk would have to be checked, and if it's not acceptable, then the tasks would have to be marked as not done, and then the development would continue in the next sprint. So, on to the integration. I have to admit that this is something that we have the least experience on from the security point of view. But most likely you would be well advised to split those features that need some sort of regulatory audit or something like that from the rest, so that you can actually have a more rapid release cycle for those requirements that do not have a regulatory audit requirements, and then have a slightly slower release cycle for those that actually do have an audit requirement. But the most important thing that happens in the release phase actually involves the product owner. So the product owner, remember that in the requirements engineering phase, the product owner was the one who actually added the security features on the requirements list. And also the product owner is often present in the sprint review, so he gets the information about things that have not been addressed properly or things that have been addressed properly. So he's the one who can make the decision on the feature level, on the user story level, of whether something is good enough to be released. So this sort of activity should be somehow tied into the releasing process. Now, it's a good question of how the information about the found threats and found risks and residual risks should flow in this organization. But this is something I have to leave also for the target organization to decide, because everybody's got different requirements for documentation. Something that I've been advocating is just a simple wiki page, which is shared by the Scrum teams and the product owner, and both of them have the ability of adding stuff to that wiki page and then also prioritizing it and producing reports out of it if necessary. So, how would this then fulfill the lean requirements? Now, this tries to pull the security requirement definition as early as possible in the process. So in that sense, we try to do things as early as possible. So yes, that particular requirement would be met. Also, we do not have in this model any sort of security team that would have to be consulted before going forward. So the Scrum team has the business ownership of their code, because they have that ownership anyway, because they're writing that code. It also makes sense to give them this ownership and the decision capability in terms of security. Obviously, the product owner or the client can veto their decision if needed, but they don't have to get a approval from somebody else. Now, this is something that I know that some people will feel a bit uneasy with, but I think that it's better to give the power to the developers than try to micromanage security on the team level. It just requires very good training and expertise from the development team. Also, in terms of variability, this should work pretty well, because now the threat analysis is applied to every feature and every task, which means that it becomes business as usual. So everything that you do on an almost daily basis is bound to be optimized very well. And of course, the threat analysis size is also pretty small. The batch size is small, so we don't have, in this model, we don't have these all-encompassing huge threat analysis anymore. Although, I have to say that if you start using this process within your team, I would very strongly suggest you do first kind of a baseline threat analysis and then do incremental analysis on top of that. About the feedback loops and decentralization, there are really two independent feedback loops. The other is actually in the brain of the product owner, and the other one is within the Scrum team. So because they are very close to each other, feedback should flow pretty rapidly, and because every product owner and every team is doing it, this won't go down if some of them, for example, leaves the company. So there's no single point of failure. And about making work visible, I think this is also one of the big benefits of this model, that I tend to compare agile processes and traditional processes to kernels. So agile process is like a microkernel. It's only a task scheduler. It doesn't offer any other services to the processes. A monolithic kernel like Linux, of course, it has your file system and everything, and it even cooks your food and whatever. The difference is that if you have a microkernel like Agile process, everything that you do will be allocated a specific time slot, and all the work is visible, and there is no implicit work that is just supposed to be done. And this way, the time spent on security is easier to measure, and also there's less competition about what you would be using your time for. So if you have a specific clear task which you need to do, you can take your time and do that task. So that applies also not only to threat analysis, but also for compliance requirements. So if you have a document, for example, that you need to fulfill so that you're in compliance with some requirement from a regulator, just make that a backlog item and it will get done. If you think that that will implicitly materialize as a side effect of your process, it won't. Non-functional requirements are a tricky subject because non-functional requirements are qualities, and it's very difficult sometimes to actually write a quality in terms of positive requirements. But the most important non-functional requirement from the security perspective, in my experience, is testing. So you have to do testing, and in my opinion, it's pretty easy to translate that into positive requirement. So if you have a requirement to robustness test or fuzz test a product, you can just write a task that says that create the fuzz test cases and put them into the continuous integration test system, and that should take care of it. And finally, something that we found really useful are dedicated security persons in every team. And now I have to underline that this is not the person that single-handedly takes care of all security, but this is a kind of security conscience, a kind of a person who has the license to pester people about security issues. So, for example, in sprint review, somebody has to ask the question that whether they are done from the security point of view or not. Now, if the team is not done from security perspective, the person that asks this question is a kind of well, it's a difficult role to be in the role of asking those hard questions. But if you have been given this role, and if you have taken this role, you have a mandate to ask these difficult questions, and so the question gets asked, and then basically the